Welcome, everyone. Thank you for joining today's Azure Power Lunch. The topic for today is Azure Database Services for MariaDB. Just a little bit of background information on MariaDB. MariaDB is an open source database platform. It was basically kind of worked off of MySQL a few years back. And a little bit of trivia there. So MariaDB was actually named after the lead developer's younger daughter, Maria, who also named MySQL after his other daughter. So just a little bit of trivia there before we get started. So MariaDB, Azure Database Services for MariaDB is the Azure platform as a service offering of MariaDB. MariaDB being an open source, as I mentioned, open source platform. This is more of now speaking for the Microsoft offering. The Microsoft offering within Azure Services, this database as a service, is a community version. That's what it's basically used off of. It is not a forked version. So this comes from the 10.2 community version of MariaDB. So just a little bit more information as we get started. So for the agenda, we're going to have some recent updates. We're going to have a look. The topics are going to be more geared towards DBAs and IT admins. And then there's some Q&A time at the end in case you have any questions. One other thing I'll point out and mention is, of course, that Microsoft is a proud sponsor, proud supports the MariaDB Foundation. Azure is a platinum sponsor, so Microsoft is a platinum sponsor for the MariaDB Foundation. So I want to point that out as well. Now, as far as the recent updates, so kind of want to start off with from December, even though it was 4 months ago. That's when with Azure Database Services for MariaDB actually went GA. Was back in December of 2018. In January, one of the things that went GA was the ability to move MariaDB servers to new resource groups and subscriptions. Then in February, virtual network service endpoints, which we'll talk about here in a few minutes, went GA. And then as recently, just a few days ago, it was announced that new compute options have been made available for GA. So the servers can actually scale to 64 virtual cores in general purpose and 32 virtual cores in memory optimized. And as always, you can stay on top of all updates within the Azure space by going to azure.microsoft.com and then to the updates section, which you can follow through this link. And then you can put it in there for MariaDB and then follow it there. So some key topics that we want to cover. One, availability performance, security and compliance, some manageability, monitoring, tuning, and then some integration topics. The first one, of course, high availability is always a key pressing item, especially from a platform as a service offering, because that's something that you would not have to worry about from your perspective. So high availability is taken care of for you on the database as a service offerings, including the open source platforms, MariaDB being one of those. You do maintain the 99.99% SLA, as you do with the other platforms as a service offerings, database as a service, such as Postgres, MySQL, Azure SQL DB. Now, some of the other benefits you actually get related to availability and performance, right, are also geared towards that aspect of the cloud offering, which is the ability to scale in seconds. And I'll go in here and I'll do a little demo of the screen and how it actually looks if you were going to use a portal. But you could also use the Azure CLI, and you could use Azure PowerShell to be able to scale that. You have the ability to have disaster recovery via backups that are geo-dispersed. So you have a couple different options there when you do set up your backups. One is locally redundant and geo-redundant, and that's determined at provisioning when you actually go to provision the resource. And that's more for the disaster recovery aspect, so you can recover from the geo-redundant backups, assuming that you have selected that during the provisioning process. That one big key piece from a platform as a service is that you build it on your terms, right? So you have that ability to scale for your performance needs. Now, as far as how that high availability kind of works out with the open source platform for Azure Database Services for MariaDB, you would normally have your applications connecting to your service. From your perspective, you point it to the server, you put your login, and everything is good from that perspective. But there's a couple pieces in addition to that happen behind the scenes that you don't have to worry about. One aspect is there's a gateway that you actually connect through, right? So when you specify that server, which is your server name .mariadb.database.azure.com, and you point it to that port, it actually goes through the gateway that points it to the actual server which it resides on. Now, in addition to that, you also have Azure Storage. That's where your data is actually stored. There's actually 3 copies of that data for reliability and for redundancy. So let's say that you had one piece of storage actually go down, one copy of that. There's actually, if one of those copies actually goes down, a third copy is automatically maintained, brought up, and that that data is replicated to that other storage container, so that you always maintain that 3 copies of your data for redundancy. Now, the second aspect of that, right, for that high availability is not just the storage, but also the compute. So what happens if your compute, your actual MariaDB server goes down? So if the server actually encounters an issue, a new server is actually brought up very quickly in its own lightweight container, and then that's actually pointed to the storage, and in the gateway, which keeps track of where your server is actually located, will then kind of update this DNS entry and then point and move your traffic to that other MariaDB server. So from your perspective, this all happens behind the scenes. You don't have to worry about it. It's handled for you. But that just kind of gives you kind of an idea of actually how the high availability actually works and how we're able to maintain that 99.99% SLA. Now let's say, okay, well, what about when I scale? If I want to scale storage or if I want to scale compute, and how do I maintain the high availability with the scaling process? Well, the process actually works kind of the same way from the compute side. Basically, you say, okay, I want to scale this to a higher tier, more vCores, so I can process more data. As you do, that is actually brought up, and then your traffic is redirected to that server. The storage scales on demand. That doesn't impact it, so it would just increase storage if you decided to scale your storage up. One thing to keep in mind with the open source platforms as a service, database as a service, as you scale up your storage, you have the ability to scale up the storage, but you can't necessarily scale down your storage. So keep that in mind with storage. And there's a couple other things with storage, in particular with IOPS, which we'll mention here in a little bit. Now, keep in mind, with security and compliance is always an important topic, an important issue. Right now, with Azure Database Services for MariaDB, you have the native authentication for MariaDB, which you can actually leverage to create your logins. You also can control your access via firewall rules, and of course that VNet service endpoints, which recently went GA. We also have the ability to have SSL connections. So SSL connections is enabled by default when you provision your Azure Database Service from MariaDB, when you provision a server. But now, granted, you can always disable it. That's an option that you actually have. Recommendation, of course, is to always leave it enabled, so you can have that secure communication and to your actual server, your databases. There's built-in encryption at the database level, right, at the data storage level. So you have that encryption taking place. Also, your backups are encrypted. And of course, with the SSL connection for your connections, you have that encryption as well in motion. You also have the advantage of the compliance that's automatically handled for you, so the leading compliance offerings. So that part, as far as the way the services are actually maintaining that compliance, that's behind the scenes, that's also maintained. Now, from a manageability perspective, right, and we'll get into each one of these topics a little bit more in depth here briefly, but you also have built-in backups and restores, and you have the ability to have the monitoring and alerting, which the monitoring and alerting is used with metrics and some other mechanisms. And of course, alerting you can turn on off based off those metrics to get notified of, let's say, certain thresholds are reached, whether it be a CPU threshold, an IO threshold, storage level threshold, something of that nature. Now, specifically with backups and restores, with the Azure Database for MariaDB, since it is a database as a service or a platform as a service, the backups are built in, so that's handled for you. Now, when you provision resources, I kind of mentioned a few minutes ago, when you provision your server, you choose if it's going to be locally redundant or geographically redundant backups, and that's set at the provisioning time. Just as a best practice, just keep in mind that can't be changed after provisioning, so you want to make sure you pick that. Recommendation for production workloads is geographically redundant. That provides you the ability to say if there's a disaster recovery need, you can recover from a geographically dispersed location as far as that storage backup to restore your server. And when you restore the backups, it restores the server with the databases on those. You also have the point-in-time recovery up to 35 days with a minimum of 7 days capability. So you do have that point-in-time recovery that you can use when restoring those databases and that server. From a monitoring and alerting perspective, Like I said, there's built-in monitoring that takes place. You can turn that on and send the metrics to Azure Monitor. You also have configurable alerts and notifications that can be set up from that perspective. For an integration, keep in mind that it is an Azure Database service, right? A database as a service, platform as a service, but you have integration with other components within Azure that you can actually leverage, whether it be virtual machines or some other processes like container services, some Azure functions, machine learning, stream analytics. So there's integrations that you can actually take advantage of and leverage within the Azure space. Just in summary from the overall overview, you keep in mind that the platform as a service helps you as far as like things like purchasing hardware and everything that you don't have to worry about, because that's actually handled for you, the underlying hardware and the management of it. So you can scale on demand. You can do the point-in-time restores. You have the high availability implementation that's handled for you and guaranteed for you. You have the disaster recovery implementation through the geo-redundant backups. There's compliance of the actual service itself. There's also other aspects that you don't have to worry about, like updates to the service. So like for instance, there's a security update to that community version 10.2. So it was where it's currently at. So if there's an actual service update, keep in mind that's slightly different from an update. So that's not going from like a 10.0 to like a higher version or overall version. That's more of the service updates. So like if there's a particular service update to fix a security issue or something of that nature, those service updates are handled. And of course, you also have the ability to tune and maintain with easy to use features. And I'll explain some of those features here in just a minute. This is just kind of briefly mentioned. There's common workload patterns that you can actually leverage and utilize for the service. So that goes back into the integration or the Azure integration, so that you can actually leverage different capabilities and then plug those into your database that's running within the Azure database for MariaDB service. And that includes things from your applications to cognitive services to basically even ML. So if you want to run some ML, some training and predictive experimentation analysis on your data sets. So just keep in mind that as an overall, there's different workload patterns you can actually leverage with your MariaDB. From some best practices point of view, keep in mind that the basic tier, which has variable IOPS, is more geared towards small websites or dev test workloads, more so towards the dev test workloads. And of course, with general purpose memory optimized gives you that better price performance benefit. Your max connections scale with your number of vCores, and also your memory available scales with your vCores. So keep that in mind too as you scale and as your needs change depending on your workload patterns. You may need to change your vCores to gain more connections or more memory. Also, your storage IOPS scale with your actual storage that's provisioned, with up basically 3 IOPS per gigabyte. The max cap right now is at 6,000 IOPS. So just keep that in mind as well. If you want to have make sure that you're taking advantage of the full IOPS capability, then you have to make sure to scale or provision your storage as necessary within the general and memory optimized. Keep in mind that the basic tier is variable IOPS. From a monitoring tuning perspective, a little bit deeper information on that is, again, as I mentioned, you have built-in metrics that you can actually capitalize on. Everything from CPU percent, IO percent, storage used, things of that nature. And then, of course, that can be integrated with Azure Monitor, so you can actually stream that and utilize that and for different purposes, whether or not you want to visualize it, run queries against it to find out how the different metrics how it's performing overall at specific intervals, or if, say, that you want to stream that to Event Hub and capitalize via a third-party or custom application, you could do that. That's more geared towards the Event Hub aspect of it and streaming that data. You can also store those metrics to blob storage for archival purposes or for your own auditing or offline reporting if you so desired. With the service as a whole from MariaDB, you do have access to certain things that you're going to be familiar with if you've used MariaDB, the information schema, performance schema, and sys. And that's more geared towards that monitoring capabilities and more information gathering of the system. So if you're familiar with MariaDB, you have those capabilities, keeping in mind that it is based on a community version 10.2 currently. So also there's some best practices that are usually recommended. Always make sure to monitor your storage, use storage percent, keeping in mind that if you get below a certain amount of storage provisioned, then your database could go into like a read-only mode. So your best practice is to monitor your storage percent, and potentially set up your alerting, which you can do to keep track of that storage and be notified of when it reaches certain thresholds. You also want to make sure that you scale up your storage before hitting that limit. Another good practice is, of course, monitor your I/O consumption percentage. Keeping in mind, as I mentioned before, that your IOPS scale with your amount of storage that you have provisioned. With that, of course, that's 6,000 IOPS maximum. So, as you reach closer to 2 terabytes, anything over 2 terabytes, you wouldn't scale in the IOPS. But keep in mind that if you're below the 2 terabytes, if you're reaching your thresholds and you're seeing a high I/O consumption, you may need to scale and provision more storage to be able to reach the higher I/O potential. You also want to keep track of your CPU percent and memory percent as well. As I mentioned before, the number of vCores that you have provisioned, it would be impacting the amount of CPU and memory that you have available, and also your number of connections, right? So just keep that in mind. You may need to scale your vCores if you're running into any potential bottlenecks there. And again, you can monitor this through the metrics and either through the visualization tool on the portal. You can use Azure Monitor, or as I mentioned before, you could stream it or send it to blob storage. You also want to make sure you monitor network latency, especially if you're connecting from an application that's running within a virtual machine. One good practice there is, if you see anything that seems like all of a sudden is performing more like some kind of latency there, is to run select tests from the client. And also you want to make sure that you enable the accelerated networking from the VM if you're running that application within the VM. As far as server logs are concerned, you do have server log capability for MariaDB, specifically that slow query log, which provides more insights into slow queries if you're familiar with utilizing MariaDB currently. And that can be enabled. Best practice, though, is, of course, to leave slow query log disabled unless you're using it to investigate a performance issue. Because, of course, whenever you enable logging, depending on how much logging you're enabling, it could always impact your performance because you have that little bit of extra overhead when you do enable slow query log within MariaDB. So just keep that in mind. But you can enable that through the various tool frames, so you can actually do it from the portal. You could also do it from other methods as well, like, say, for instance, the CLI or the PowerShell. You also, in addition to having server logs from a monitoring perspective, is you can also use Explain. If you're familiar with MariaDB and using Explain, you can run that as well. And so if you're familiar with using it, this is just one example. And you can find a little bit more information about this online on using Explain, but it'll provide you information as far as troubleshooting performance issues from your queries. The example that's actually shown on there is from the Microsoft documentation, and it actually shows an example of where a query is being run and doesn't have a key, and so it's having to pull back a ton of rows to be able to find the result set. While in that's one that's labeled number 1, and the one that's labeled number 2, you can see where a key was added and the difference in the rows that are the row set. So if you look at where it says rows, it went from 995,789 to 1. So just keep in mind that you can use Explain in addition to. So if you're familiar with MariaDB, you can use it within the Azure Database for MariaDB services as well. From a business continuity aspect, just a little bit deeper information, and we covered a little bit about this already, is just keep in mind you have those built-in backups with a retention up to 35 days. Those are encrypted. And again, you do have that locally or geographically redundant storage that you pick at the provisioning time. The restore from locally redundant, it gives you that RPO 0. If you have the geo-redundant backups, it gives you the RPO less than or equal to 1 hour. From the best practices perspective on business continuity, again, as I mentioned earlier, the practice is to pick the geographically redundant option for your storage and backups, especially on production systems, so that you have that capability to restore across regions. And also, a couple other things to keep in mind is the big one is, like as I mentioned previously, you can't change that backup redundancy option once the server is created, so that's set at provisioning time. Items from a security and compliance standpoint is, from the security as a whole, it's a kind of a layered approach. So you have of course, you connect from the internet. That goes through that Azure Edge network protection, which basically will send you through the gateway, and then that gateway will then connect you into your MariaDB based on your native authentication. You also have those firewalls, so keep that in mind as well, which I'll show you here in the next slide. But just keep in mind that you have that, so it connects from your internet to the gateway, to the Azure network protection, to the gateway, and you use native authentication to set up your logins within MariaDB. Now, as far as the firewall is concerned, it does use SSL. TLS 1.2 is enforced. Now, at the MariaDB level, at Azure Database Services from MariaDB, you can always disable SSL. Again, recommendation, keep it enabled. From the standpoint of the firewall, that's basically preventing access into your Azure Database from MariaDB. As you can see from that second graphic, more towards the right bottom there, as traffic tries to come in, it's going to hit that server level firewall and determine whether or not it has access. And you specify the IP ranges or the IP address that would or will not have access. If it fails, it can't connect. If you have given it access, then of course you can reach in, and that connection can then try to establish a connection to the databases. Then it checks the native authentication to see if it can log in. There's a couple more pieces here. Again, more geared towards the security and the connection information. And the other thing that I want to make sure to mention on security was the VNet service endpoints. VNet service endpoints has that ability. You have the same thing with other open source ones for like MySQL, PostgreSQL, and it's also the same as you would have with Azure SQL DB, if you're familiar with that. And this gives you the ability to basically, you would disable the firewall, allowing not allowing any traffic into your service, your server, Azure Database Services from MariaDB. And then you enable the VNet service endpoints for the VNet on that, and then any traffic that comes through that VNet off the subnet specified for that VNet that's tied to the service is what would be able to reach your Azure database for MariaDB server. Any other traffic it would not respond to. So basically allows it to say, I don't really respond off the traffic that's coming from outside. It would only respond via the internal VNet within Azure. And you can link that up with other VNets within Azure, the peering and VPN. But just keep in mind that that's a way of making it more of that private access, right? It is the same service, which is Microsoft.SQL service for Azure SQL DB, as well as Postgres, MariaDB, Azure Data Warehouse, and MySQL. So keep that in mind that when you enable it for that service, you're enabling that service for the other ones as well. One thing I kind of wanted to call out real quick on integration is just replication. So you do have the MariaDB data in replication available within the Azure Database Services from MariaDB. With the data in replication, if you're not familiar with it, basically the way it works is you basically set up the master and the slave. In this case, the master would be more of the on-prem or virtual machine or database hosted in another provider. And then you would set up the slave as your Azure Database from MariaDB. And then you would set up the connectivity between there. There's different commands you would have to run, and then also to be able to set that up. It's geared towards general and memory optimized tiers. It's not available within the basic tier, but it is available for general and memory optimized tiers. And of course, the master and slave both have to be the same version. Currently, the version that's supported for Azure Database Services from MariaDB is 10.2, so they would both have to be running at that same version of 10.2. And of course, the master should use the InnoDB engine, which is what is being used within Azure Database Services from MariaDB for that 10.2 version. If for those who are familiar with the actual engines, InnoDB was the engine that was used to replace my ISAM, and it provided more of the ACID capabilities. So that's kind of more geared towards that. Just a quick switch, just to show you real quick. Here is an example of a MySQL Workbench connecting to an Azure database from MariaDB. One of the things I kind of wanted to point out with that is, if you notice on the left side here, the way you specify the server is the server name. In this case, this is my server name, .mariadb.database.azure.com. But the one key piece I want to point out is the login. So when you're specifying the login information and you're connecting, and in this case, I just created a test user. But you notice I had to use the @ with the name of the server. So this part is required for your login, which helps it to determine, that's all part of the way that it actually processes it and makes sure that you're connecting to your database. So this goes in connection with your host name and your database. So that's all important. So just remember, if you are setting this up and you're leveraging the resource, make sure to, when you set up your login and you try to connect, that you don't just use the login, you use the @ and then the name of the server to make sure that you can actually connect and authenticate. If you don't, then it wouldn't be able to authenticate correctly. That's the big piece that I wanted to show here and highlight. And then this is, of course, this is MySQL Workbench. If you're familiar with that, you would be able to utilize that when you're working with Azure Database Services for MariaDB. Nothing too fancy here. I had a query here just to load some data. And of course, just a quick example on some GIS data just to show that working as well. But we'll go ahead and switch. I know we're running close to time. So are there any questions about the Azure Database Services for MariaDB?
I guess this is too simplistic of a question, but what's the difference between MariaDB and MySQL in general?
So MariaDB and MySQL, MySQL came first, right? Of course, MariaDB was more of I want to call it a fork of MySQL, so that came second, right? It was both came from the same lead developer, and MySQL, of course, when it was acquired by Oracle at the time, MariaDB kind of came out to basically provide as an alternate open source platform. MariaDB, right, of course, is fully open source, and it will always be open source, and it's maintained and I guess you could say addressed via the MariaDB Foundation, right? There are some, for the most part, a lot of people think, okay, well, this is going to be an equivalent for MySQL that I can then move from between the two. There are some slight differences, but you'll notice a lot of the similarities, right? Like, for instance, you use the same tooling, like you can use MySQL Workbench, et cetera, to connect to both because they all have that similar platform. Right now, depending on the version of MySQL, you may have a different storage engine, right? So there's a couple different storage engines depending on the version of MySQL and also MariaDB as well. Right now, I think it used to be Aria, one of the storage engines. My ISAM was another storage engine that was used for MySQL, and of course NODB, which is the storage engine used for MariaDB 10.2. And a couple other versions would be more towards Aria is being used also for MySQL as well. So the underlying storage engine does provide a little bit different in capability. For instance, depending on the storage engine, you may not have ACID compliance, right? And then some other capabilities. And the way they actually work is slightly different between those three storage engines. But MariaDB in this particular instance would be using more the NODB or INNODB storage engine. So depending on the storage engine, that can provide a little bit different in capabilities and what it can do. MariaDB, of course, being in this particular sense, this one being more the ACID compliance, which also MySQL can also provide, and depending on the version you're using. So a lot of it also depends on versioning, right? Of what capabilities you have. But you're going to have some similarity between the two, of course. Like, for instance, GIS data between MariaDB and MySQL. A lot of the same commands will work between the two. But also, like I mentioned, a lot of it has to do with the storage engine used, right? And that depends on the version of MySQL you're looking at, because depending on the version, as mentioned, there's three different ones, right? NODB, Aria, and MyASM. Hopefully that helps.
Yeah, that's very helpful and detailed answer. Thank you. So I guess there is no paid version for MariaDB. It's all free always.
Yeah, MariaDB is supposed to be open source, freely available. There's now some people may fork it, right? So of course, with any open source platform, there's always the potential that someone may try to do a fork of the implementation and call it something else. But MariaDB as a whole is really meant to be open source, and people are trying to keep it open source. So MariaDB is really an open source platform, and as opposed to other options that may exist out there.
So are we providing support on Azure then?
Correct. So this support for the Azure Database as a Service offerings is through Azure, right? So you can also, if you're having issues with the platform, you can open a support ticket. So that's actually handled here. Now, of course, updates to the service, the community version, right? So there's two different components there, right? So this is based on the community version because this is not a fork. That's the one thing to always keep in mind is the open source platforms that we're utilizing within Azure are not forks of those open source platforms. They're based on the community versions of those platforms. So in this case, MariaDB, it's based on the community version of 10.2. It's not using a fork. It's not using its own version, I guess you could say, if you will, with alterations. It's just taking that and then leveraging that to provide a managed solution that you can then leverage to handle, your backups, any security updates, those kind of things, and then the high availability is handled for you, et cetera. But if you run into any issues with the service itself, you would of course open a support ticket, and Microsoft in the Azure support would actually help you out with that service.
Yeah, but beyond Azure, there is no database vendor backing it up if my data gets corrupted or something like that.
If your data gets corrupted, right, and there's an issue with your data, right, you also have other mechanisms you can try to retrieve the data from your backups. That gives you the point-in-time recovery. So depending on what your issue is there, right, that of course you would have the point-in-time recovery that you can restore from, because you do have that as part of the managed solution. So that support is there for you to help you recover your database, right, especially from that perspective, right? So let's say that something happened that your database is having issues. Again, that's where you would run in and enter in a support ticket for your service within Azure, and then you would get the Azure support to help you out, and then try to get you back up and running from your database backups, right, to be able to recover from that. Any other questions?
I don't see any question in the IM window. Thanks, Tom.
You're welcome, Naveed. If there's no other questions, I guess we can go ahead and stop. You'll give one more chance in case anyone has a question they want to throw out there real quick.
Just a couple of questions about security. Is this MariaDB considered mostly for like non-production development?
Nope.
And then,
oh, sorry, go ahead.
And then also, could you open up the users and privileges? I mean, are there like admin roles or security roles, or how robust is the security here?
Gotcha. So it's not just for development and testing. This can be used for production workloads. That's now the one thing to throw out there is if you're going production workloads, usually recommendation is to use either the general or memory optimized, either general purpose or general business or memory optimized tiers, as opposed to the basic tiers. So there's 3 service tiers. And the real reason for that is a couple different things. But one thing to keep in mind, of course, is that capability for your IOPS. You don't want to have variable IOPS usually on your production workloads unless it's extremely small. You want to make sure you can maintain that certain level of throughput, right? So, but it is geared towards production workloads, and there are companies that utilize MariaDB for production workloads. So that's to answer the first question. It's not just for dev and test; it's also for production usage. But
so it runs on a Microsoft cluster, failover, all that sort of thing.
Yeah, so your high availability, that's all handled for you, so you don't have to worry about that. You'll have that 99.99% SLA. So backups are there. All of that's handled for you. So you can definitely use this for production workloads. Like I said, the only recommendation is general or memory optimized, usually recommended for production workloads, not basic. Now, the second aspect of that is with the logins, right? So from a security standpoint, you create the logins and you're in control of those logins from an administrator standpoint. You don't have, of course, this is a database as a service, a platform as a service, so you don't have access to the underlying infrastructure, right? So you don't have and you don't have access to the underlying OS and the container, the lightweight container that the node actually, the compute node runs on. So you don't have access to anything at a file system level, right? So that part you can't do, but you have control over your users and privileges within the database itself, so that you can give access to people to be able to do things within the database. Just not at a level that would be something that would be at a certain level higher, right? That you may be familiar or not familiar with, as far as if you were going to be setting up access to do things from depending on what you're trying to do, you may or may not have that capability, right? So there's multiple layers of control. So there's a service layer security, which is handled through role-based access control, or RBAC, for the access control lists for the service level, right, which is more like within Azure, so you have permissions within there. And then when you drill down into the service itself, and then you have your database, and you have your privileges that you associate at the database level for your objects and what they can do within the database. Does that help?
Okay, appreciate it. Yes, it does. Thank you.
You're welcome. Any other questions? Give it just a few seconds here in case someone else has another question. If not, we'll be wrapping up. All right, Naveed, it sounds like we could probably go ahead and wrap up the call.